Alright, so we're at part 1 for our Unit 5 project. A wheelchair ramp requires specific ratios of height to length to make them usable by people who use wheelchairs. In this project, you'll investigate the angles and distances of these ramps. The Americans with Disabilities Act, ADA, requires a slope of no more than 1 to 12 for wheelchairs and scooters for business and public use. Consider the following problems. A new store will need a ramp whose angle of elevation, the angle formed where the ramp touches the ground, is 3.5 degrees and whose length is 36 inches. In triangle ABC, angle A is the angle of elevation and segment AC represents the ramp. Alright, first thing that I'm going to notice is the ratio is given a height to length. So this 1 represents the height and the 12 represents the length part. And then our question is, does the ramp of the new store comply with ADA? Why or why not? You will solve the problem step by step. Okay. The next thing that I want to notice is this is the diagram that they drew for the ramp for the new store, and the angle of the elevation is angle A, which is right here. So that means this is the ground, and this is the ramp. So A to C is the length of the ramp, and we need to know how far along it travels along the ground or how high it is. Now, question 1, it says, which trigonometric ratio could you use to solve for side length BC, the height of the threshold to the store? Alright, side length BC is right here. And this is how I'm going to ask myself how to decide which trig ratio I need. So I'm going to look from the angle of elevation, which is angle A. So my perspective is angle A, and that means I need from angle A, CB is the opposite side, and 36, or the length of the ramp, is our hypotenuse. Then I'm going to think back to myself, which trig function is the ratio between the opposite side length and the hypotenuse, and that is the sine. So we're going to have sine of our angle, so sine of A is going to equal our BC over our hypotenuse, which is 36. So for the first question, it is sine of A. So for the first one, the answer is going to be sine of A. Right here, I'm just going to take a pause and give you two mnemonic devices that will help you remember the ratios for our sine functions. First one is called SOHCAHTOA. So is sine opposite over hypotenuse. So we have SO. Ka is cosine is adjacent over hypotenuse. So there's our ka. And TOA is tangent is opposite over adjacent. Alright, so there is one mnemonic device that will help you remember the ratios for what the side lengths are for sine, cosine, and tangent. The other one is some old hippie, SOH, some old hippie caught another hippie, CAH, tripping on acid, TOA. Now, that's not endorsed. It is just a funny way to remember the ratios for our trig functions. Alright, so now question 2. Solve for side length BC in the previous question. Round your answer to the nearest tenth. Alright, so we need to set this up. We have sine of our angle A. So we're going to set it up. Sine of angle A is equal to the ratio of our opposite side length, which was BC, over our hypotenuse, which is the side length AC. So now if we use our substitution property, we will have sine of 3.5 is equal to, I don't know the side length for BC, so I'm going to use x divided by the side length for AC was 36. Now, sine of 3.5 is a number. It is our ratio. And so I'm going to type that in, sine, parentheses, 3.5, close parentheses, and hit enter. Now, if you notice right here on your calculator, there's an RAD, and if you click it, it's DEG. You need to make sure that the DEG, or degrees, is showing, because 3.5 was given as a degree. So if we type that in, we'll click sine of 3.5 and hit enter, and that number is 0.610. So I'm going to write it down as 0.0610485. And I'm technically rounding, which creates an inaccuracy. So a lot of times people will leave it as sine of 3.5. So that number equals x over 36. In order to solve for x, since it's being divided by 36, we can multiply by 36. So we're going to multiply both sides by 36. So 36 times the sine of 3.5, since this was what sine of 3.5 is equal to, I'm just going to hit times 36. And that's going to equal 2.1977. 2.1977. And that is going to equal x over 36 times 36 results in 36x divided by 36. 36 divided by 36 is a form of 1. So then we are left with 2.1977 is equal to x. 1x. In math, 1x is often just written as x. So we have x equals 2.1977. So that is our side length for BC. And it says round to the nearest tenth. So if I want to round to the nearest tenth, and right here, I'm going to look at the hundredth place and ask myself, is it 5 and above or 4 and less? Since 9 is 5 and above, that means 2.19 is closer to 2.2 than it is to 2.1. So this will be 2.2. Question 3. Which trigonometric ratio could you use to solve for side length AB? So again, if we refer to our picture, we are going to use the angle it's giving us as our perspective. And it wants us to find the side length AB. And I'm going to ask myself, is side length AB the opposite or the adjacent side? And it is the adjacent side. And 36 is the side length that is given, which is our hypotenuse. So I'm given an adjacent side length that I want to find, and I have the length of the hypotenuse. So I would ask myself, what trig ratio has the ratio of adjacent to hypotenuse? And that is cosine. So I'm looking for the cosine of A, because that was our angle of reference. So we're looking for cosine of A. Solve for AB in the previous question. So we're going to set it up similarly. Cosine of A is going to equal side length AB, because that's the adjacent side, divided by side length AC, because that is our hypotenuse. And by substitution, we will write cosine of 3.5 degrees is equal to an unknown. So I'm using X. You could use Y, you could use T, you could use A, little a, some variable to represent an unknown. And AC was 36 inches. So again, cosine of 3.5 degrees is a number. I'm going to leave it as cosine of 3.5 right now, just so that I'm not writing that decimal out. So then I'm looking at x divided by 3.36. Since I need to solve for x, I'm going to multiply both sides again by 36. Multiply both sides by 36. Then I'm going to say, okay, well, we have 36 times the cosine of 3.5 is equal to x divided by 36 times 36 is 36x divided by 36. Alright, so now let's simplify. This is a number because cosine of 3.5 is a ratio. So I'm going to type in 36 times cosine, make sure it's in degrees, of 3.5. That equals 35.93. 35.93 is equal to 36x divided by 36. 36 divided by 36 is a form of 1, so I have 1x. And in math, 1x is represented as x. So we have our length of AB is equal to 35.93. We want it rounded to the nearest tenth, so I'm going to look at the hundredth place and ask myself, is it 5 and above or 4 and below? Since 3 is below 4, that means that 35.93 is closer to 35.9 than it is to 36. So our length is going to be 35.9 inches. Does the ramp of the new store comply with the ADA? Why or why not? Alright, we've got to remember what the ratio was for the ADA, which was 1 to 12. So, and remember it was the height to length. So we found our height and we found our length. So now we need to set up a proportion to see if it is. So we have our length, which was 39.5, and our height, which was 2.2. So our height is 2.2, and our length was 35.9. Okay, we're gonna set up a proportion. So I'm going to leave. Okay, this is what we're gonna do. Does 1 compared to 12, that's the ratio from the ADA, does that equal the height that we found, 2.2, compared to the length, 35.9? So we're checking to see if this does or does not equal our same ratio. So if we go to our calculator, 1 divided by 12 is equal to 0.8333 repeating. So we have 0.83 repeating. Does that equal 2.2 divided by 35.9? That is 0.6. One, two. I think I got the zero. So then I asked myself, okay, well, is 0.083 the same as 0.06? And no, it's not. So no, it does not comply to the ADA because the ratios for height to length are not the same. So then when you type in your answer, we want to type in, I'll give you an example. So no, the ramp does not comply with the ADA. The ratio for height to length of the ramp is 0.0612, and the ratio, which is smaller than the ratio for height to length of the ADA required ramp, which is 0.83. So 0.083. So what does that mean? Does that mean it is steeper or shallower than what our ratio is? And that means that it is shallower since our number is smaller. If it was, if our number was greater than 0.83, that means that our ramp would have been, the steepness, the slope would have been greater. So that means it would have been too steep for the 80. This one is too shallow, so it needs to be increased just a little bit since these two numbers are really close. So there is our explanation for if the ramp complies or not. And we're going to save and exit, and we'll see you in the next project part.